In this video, we are going to discuss a transportation model, and more specifically, this transportation model will be unbalanced and it will be having some prohibited routes. So it's about a mining company that has four mining sites which are located in different parts of region. The weekly production capacity of each mine is shown in the table. So for the Alpha mine, it is 90, for Bravo 50, for Charlie's 80, and for Delta 60. So total capacity is 280 tons. These mines, they are supplying coal to three plants, and the plant 1 has the demand of 120 tons, plant 2 has a demand of 100, and plant 3 has a demand of 110. So total demand is 330 tons, and which is clearly greater than the demand than the production capacity. So the cost of shipping is given in the last table, as you can see. So for the cost of shipping from the Alpha mine to the plant 1, 2 and 3 is given here, and then for Bravo and Charlie and Delta is also given here. So, and a very important condition which is mentioned here is that due to some infrastructure issues, Alpha mine is not able to ship to plant 1. So that means although the value of 7, which is in thousands of dollars per ton, it is given for Alpha mine to plant 1, but this route is not permissible. So the three tables have been combined on this slide, and now we are going to formulate a mathematical model for it. The first thing is the decision variable. So the decision variable will be the quantity shipped from mine I to plant J, where I is equal to A for Alpha, B for Bravo, C Charlie, D Delta to plant J, which is 1, 2 and 3. The objective function, it is to minimize cost. We will write it as minimize Z, and that is equal to the cost of transportation from mines to the plant. So using the last table, we will write the objective function as 7xa1 plus 10xa2 plus 5xa3 plus 12x b1 plus 9x b2 plus 4x b3 plus 7x c1 plus 3x c2 plus 11x c3 plus 9x d1 plus 5x d2 plus 7x d3. Now you must be wondering that why I have included this value 7x a1, because as discussed earlier, this route is not permissible. So why have we included it in our objective function? So we will come to this point in a bit, but let's first see how the constraints will be formulated. Now here, since the supply it is less than the demand, so remember, in such case we will formulate the supply constraints with equal sign and demand constraint with inequality sign. So let's first formulate the supply constraints. So the supply constraint here is supply is from the Alpha, Bravo, Charlie and Delta mines. So we will use this table which is showing the supply here. So we will write the quantity shipped from the Alpha to 1 plus from Alpha to 2 from Alpha to 3, this must be equal to 90. Then from Bravo to 1 to Bravo to 2, and quantity from Bravo to 3 should be equal to 90. Then quantity from Charlie to 1, Charlie to 2 plus Charlie to third plant is 80, and then delta xd1 plus xd2 plus xd3 equal to 60. So we have four supply constraints for the four mines. Now let's see how the demand constraints can be formulated. So demand constraints will be formulated for these three plants. So these are for demand. So the plant 1 can have coal from mine 1, it can have coal from mine Bravo, it can also have coal from Charlie and from Delta. And this, because the demand is more than supply, it cannot be fulfilled, so we will write it is less than or equal to 120. Similarly, we will write for the plant 2, which can receive coal from Alpha or the Bravo or the Charlie or the Delta, and this is less than equal to 100. And similarly, plant 3 can receive coal from Alpha, it can receive coal from Bravo or from Charlie or from Delta, and this is less than equal to 110. And finally, in addition to these 4 supply constraints and 3 demand constraints, we have a non-negativity constraint that tells us that xij should be greater than equal to 0. So this is all about the formulation of this mathematical formulation of this problem. Now let's see that why we have used here 7xa1, and although this route was not permissible to us. So uh, remember that while doing this in solver, we use a formula sum product. Okay, and the sum product is basically, it is the product of the two data arrays, and these arrays should be of similar structures. We multiply them and we add them, and we make our objective functions. So for doing this, the first option that comes to mind, that we should omit it. So we should omit it or make it, just write it 0. So these two options are interpreted differently in the solver. Solver understands that if you omit this value, this 7, and just replace it with nothing, or keep this cell empty, or you just replace it with 0, solver will take it as a 0 cost of transportation from alpha to plant 1. So we can't just leave it, we can't just omit it, or we can't just put 0 in place of this cell. And this is especially important and when we are using this sum product formula. So another option to deal such type of situation, such prohibited route, is to use a big number and replace the existing cost, which is given cost, by some big number. Since it's a minimization problem, the solver will automatically uh, will automatically avoid choosing this route. So uh, how we can handle this? So instead of writing 7 here, we will write a big number, and let's say, because if we compare the other cost in table, these are 7, 10, 12, to replace it with a big number like 100xa1. So the 100, so we are telling solver that the cost of transportation from alpha to 1 is $100 per thousand. 100 in the value is in $1,000 per ton. So when we are assigning it a big number, the solver will automatically avoid this route. So this is the way to handle this type of the problem. So we can also let's have a look at the excel sheet of this problem. So okay, now I have already formulated a sheet here, and as discussed in my previous videos, these are the 4 cells, these are the empty, and these 4 cells, the cells like here, the 4 cells I have made, these cells, they represent which quantities. The first, these cells represent the quantities like this is xa1, and this is xa2, this is xa3, this is xb1, and so on, and this is xt4, and so on and so forth. So and these 4, here we have the 4 uh, cost data from each mine to each plant. So let's say if we uh, uh, in the first option as discussed is just just keep this cell, just omit it from the objective function. That is the objective function as mentioned here. It is just starting from 10x and this one, and it goes like this. So if we just I omit it, so that means that I'll keep this xa1 cell. uh, I will not put any cost in it. So now let's see what how the solver interprets, how the solver has the interpretation of this thing. So just let me first clear the mess from here. So now uh, just a reminder to you that uh, our constraints have already been they are incorporated in this cells, this cell shift cell, which is it is the sum of, it is the sum of all these, all the sum of this row. Okay, and this is basically, this cell is telling us, it is telling us that xa1 plus xa2 and plus xa3, and we know from constraint that this is equal to 90. So the second constraint, just let me number it, 1 2 3. So this cell, uh, 1 2 3 and 4. So the first constraint is coded in the first cell, and this is for the first cell, this is for the first constraint, second constraint, third constraint, and fourth constraint. Similarly, this shift in the, if you look at the bottom, basically this is equal to the, this is if this is basically equal to the sum of the column, sum of the column. And the sum of the column means that it is showing us that xa1 plus xb1 plus xc1 plus xd1. So this cell is basically summing up all the quantities shipped to plant 1 from alpha, bravo, charlie, and delta, and this is our fifth constraint. So this cell here, it is showing the fifth constraint, and then sixth and seventh. This one is showing us the sixth constraint, and this is basically the sum of the column entries, and this is some of the this column entries, and this is showing us the sixth, sorry, not sixth, seventh constraint. So all the constraints have been mentioned, have been added to this excel sheet. And our objective is basically multiplication of 10 with this, with the multiplication of this cost data, each entry with its corresponding entry in this here, and then adding it, like uh, let's say 10x a1 or 5x a3, 12x b1. And so this is basically done by this is done by sum product. Okay, so I'll just show you the formula. The sum product of this array, all the x quantities and all the cost data. So we have used this thing. Now let's start exploring the three options that we discussed of handling the prohibited routes, and we are, remember, we are using the sum product formula. So if we are, let's say, if we don't want to use the sum product formula, how are we going to do it? Let's first see this. So if you're not using the sum product formula, you will write here equal to, then you will multiply this cell with the with this one, plus now the xa2 multiplied by 10 plus 12, which is mentioned, which is here, sorry, this is 3 5 multiplied by this plant 3, and we have to do it for all the cells, and they will be like 3 4 the 12 values we have to type it. So instead of doing this, the easy way is simply equal to sum product, and then it asks for the first array. So this is the first array of the data, all the x quantities, comma, all the cost quantities which are mentioned here. So this is how the sum product is done. So now, let's say we because this route is xa1 was prohibited, so we have not included its cost in this cell. Okay, so when we now solve it, then if I go to the solver and I just solve it, then you can see that we will get a value of uh, value of around 820. So you will get a value of 820. So because you see now the solver has assigned a quantity of 90 tons to be shipped from A to 1. Because the solver does not understand that although we have omitted it, but the solver takes it like a that it has a zero value here. So the omitting it is not a option. So let's say if I now redo it and you remember the value we got with omitting it 820, as you can see it from here. The value we got is 820. Now if I put 0 here, then and then again I solve it, and if again I solve it, then again you can see that the value I'm getting is 820. So that means, so either I put here 0 or I just omit it. The solver takes it this route as having the lowest cost, and it just it allocates the quantity to be shipped from alpha to plant 1. So this means that this route is not prohibited in our solution. So let's try the method that I told you. Let's put here 100, assigning it a big number. Now if I assign it a big number and now I solve it, and this number can be any number which is greater than the other cost values. Like we have 10, 5, 12, so we could have used 50 here. I have just written 100 here. So if I solve with 100, then we have this cost. Now if you look here, after assigning the 100, the solver has not used this root and the value is 0 here. So this is very important. So the right way to handle this is use a big value for the prohibited route, and the solver will automatically discard it. So that's all for the problem with which is unbalanced and has some prohibited routes. Remember that if you are doing a sum product formula, you should not be keeping this cell, the prohibited root cell, empty or putting a zero value in it. You should put a big number as compared to the other numbers mentioned in the table. So that's all for this type of problem. Thank you.